100 years ago, scientists assumed the universe was always basically the same as we know it today. They figured anything that changed fit within some sort of cycle. Then, in 1929, Edwin Hubble published a discovery that changed all that. That's what's up next on PS 100. Remember the Doppler effect? That's the principle that explains why the frequency of a car's horn sounds higher when it's coming toward you and lower as it speeds away. That's because the sound waves get sort of squeezed together in front of the moving car and stretched out behind it, and the distance between those waves determines the sound's frequency. Well, the same sort of thing happens with light waves, only we perceive differences in visible light waves' frequency as differences in color. So the color of a light shifts towards the blue end of the spectrum as it flies towards you, and towards the red end as it flies away. We can detect this by measuring the light emitted by the hydrogen reactions in these galaxies. Every element emits and absorbs certain frequencies of light, and no two elements are the same, so they each have a unique fingerprint called a spectral line. Since the galaxies are moving away from us, the spectral lines emitted by their hydrogen shift toward the red. You can't see this shift, but it's measurable. And we can calculate how fast a galaxy is moving away by how far its spectral lines have shifted. So Edwin Hubble took what we know about the Doppler effect and did the math to figure out how all the galaxies in the observable universe are moving in relation to one another. According to these calculations, gravity is slowly pulling a few of the closest galaxies toward us, but the millions of galaxies we've measured beyond those are all moving away. As it turns out, the farther away they are, the faster they're moving away from us. Hubble figured that if everything is moving away, then the universe must be expanding. This idea became known as the Big Bang Theory. But let's back up. The fact that the galaxies move away faster and faster the further they are from us is actually really important. That obvious pattern tells us that everything started expanding from one event in space and time. Look at it this way. When the school day ends on campus, students scatter in every direction, some going fast, others going slow. Measuring their speed and distance relative to your own position wouldn't lead you to believe that all motion originated with a specific event. It'd be almost like they were always there, just walking around. But if you were packed in the Marriott Center with the rest of the student body, and everyone left at the same time as fast as they could in a straight line from the building, you'd find that the fastest students were the furthest from you, and the students closest to you would be moving the slowest away from you. And when you look at it that way, it's clear that none of this means that the Earth is the center of the universe. If we replay that same animation and follow another student leaving the Marriott Center, we still find that everyone moves faster away from that student the further away they are. Generations of astronomers have produced evidence that supports Edwin Hubble's claim. So while the universe remains an incredibly mysterious place, we can thank Dr. Hubble for helping us understand how it all got started. That's it for this episode, but you'll find more science and research opportunities for BYU undergrads in the description below.